Okay, we're just about done with Chapter 5. In Section 5.5, we're actually only covering one objective, and this is dividing a polynomial by a monomial. So let's remember how we... Oops, I didn't write that correctly. Remember how we add fractions. If we have two fractions and they have the same denominator, if we have a plus c over b plus c, then we can just combine those together. We can say that this is a plus b over c. What we're going to be doing in this for adding or dividing by a monomial is we're basically just going to be going back the other direction. And if we have multiple terms up on top of the fraction and we only have one thing on the bottom, we can split it up based on the top part there. So this 9x cubed minus 21x squared all over 3x, I would say that this is 9x cubed over 3x minus 21x squared over 3x. And in doing this, now I can actually apply some of my, I can reduce each of these fractions individually. So you can see there's a common factor of 3. When I cancel a factor of 3 here, I'm left with a 3 up top. And then x cubed over x leaves me x squared. Oops. Let's do minus. Here, when I cancel a factor of 3, I'm left with a 7 and an x. So x squared over x is x. So dividing this polynomial by this polynomial, I end up getting, or this monomial, I should say, I get 3x squared minus 7x. And that's basically all there is to this section. I'll just do a few more examples here. Alright, so this one we'll get 12p to the 4th over 4p squared plus 24p cubed over 4p squared plus 4p squared over 4p squared. You want to avoid, a lot of people when they see this, they have a tendency to say, okay, well, I can cancel the 4p squared with the 4p squared, right? Well, no, because when you're canceling, when you're dealing with canceling factors, when you're canceling with division, what you're doing is you're canceling factors. So if you had something like 8 over 4, then what you're really doing is you're thinking of this as 2 times 4 divided by 4. You cancel the factors of 4, these are multiplied here, and you end up with 2. This would not be the same as if I said 4 plus 4 over 4, and I canceled those things. This is not equal to 4. This way does not work because, well, these are not factors. These are terms. These are added here. The only time you can really cancel with division is when it's written as multiplication. Since multiplication and division are inverse operations, that's really, there's a relationship going on there. But multiplication and addition are rather. Division and addition are not inverse operations, so you can't do the cancellation like that. In any case, let's see. So you would split this up as 3 separate fractions and then reduce each of those fractions individually. This first one, we get a 3, that's 12 over 4. P to the 4th over p squared is p squared. 4 minus 2 is 2. 24 over 4 is 6, and p cubed over p squared. 3 minus 2 is 1, so we just get 6p. And here, 4 over 4 is 1. P squared over p squared, those entirely cancel. But remember, when we're canceling using division and multiplication, when you say they entirely cancel, really there's a 1 left over. Normally that's not an issue. If you were to entirely cancel, if this was, I don't know, 8x over, 4x, if you entirely cancel those and you say there's a 1 left over, you don't really notice it because this is 2 times 1, which is just 2. But when there's nothing else left over, and especially if you're adding this to something else, you do need to actually explicitly write that 1 in this instance. So that's plus 1 there. And I don't know why. Apparently I typed these in incorrectly again. Let me consult to see what this should have been. Alright. I've written down what this actually should have been. I typed it in incorrectly. I wasn't doing spaces where I should have when I was typing it into the equation editor. In any case, if we have this 8a squared b squared minus 6a squared b plus 6ab squared all over 2a squared b squared, we'll do the exact same thing here. I'll split it up as 3 separate fractions. 8a squared b squared over 2a squared b squared minus 6a squared b over 2a squared b squared plus 6ab squared over 2a squared b squared. Okay. And reducing each of these fractions, it looks like we get some cancellation here. We get a 4. The a squared and the a squared cancel. The b squared and the b squared cancel. 4 times 1 is just 4, so I can just leave it as a 4. Here we get a 3. 6 over 2 is 3. The a squared and the a squared cancel. The b and the b squared partially cancel. We can cancel one of those factors of b with the other factor of b here. Normally when I'm canceling, if I'm canceling out just one factor here, I'm just crossing out the 2 to show this was b times b, and we end up with just a b left over. So we end up getting 3 over b here. That leftover b was in the denominator, and that's why I wrote it over b here. It's still in the denominator. And the same thing happens here. We get, with the a over a squared, we have one of the a's canceling out, but there's still one left behind in the bottom. And then each of the b's, the b squared cancels out the b squared. So we end up with 4 minus 3 over b plus 3 over a. This is not a polynomial, so there is no necessity of trying to write this in standard form. There is no general standard form for expressions unless they meet a particular class like polynomials. So I'll just leave it like this.